Existing tools for analyzing ecosystem connectivity work by calculating landscape and patch level statistics from raster land cover maps by masking out different areas. However, these methods can be quite limited in their ability to answer ecosystem questions, like tracking habitats over time. To solve these issues, we introduced the GeoGraph, a geospatially referenced graph for analyzing ecosystems and habitats, in which nodes represent patches of land and edges represent proximity between adjacent patches. The GeoGraph takes as input a land cover map, either rasterized from Earth observation data or, like this map, collected from ground survey data. From this map, we can create a graph in which each patch of land corresponds to a node in the graph and edges are added between adjacent patches. This is our interactive graph viewer, which allows for easy inspection of any of the graph properties and metrics through the panels on the right-hand side. We can also switch to satellite imagery like this, or toggle the view of the underlying data. Once the GeoGraph is created, we can add habitats as a subset of the nodes in the full dataset, created from a list of land cover types. These habitats have a travel distance around each patch that represents the distance an animal using the habitat is likely to be able to travel outside of its habitat. In this example, we have created a habitat made up of all pine forest patches, with a travel distance of 500 meters. In the components view, we can see that the 500-meter travel distance has created some large connected components representing a unified habitat. We can also highlight disconnected patches or poorly connected patches. We can modify habitats in the code by adding, removing, or merging nodes in the graph to see the effect of changes in the real world. For example, we can identify potential new conservation areas, such as this overlap region. Adding a conservation area here for this habitat would join these two components and reduce habitat fragmentation. When we have multiple years of data available, as in this example, we can examine the node dynamics across time and see if particular habitats are shrinking or growing. Here, different patches are coloured according to whether they are growing, shrinking, splitting, or merging over time. Thank you for listening, and you can use these links to find out more.